Molecular compounds. In this lesson, we're going to be reviewing ionic compounds. We're going to go over some examples. We're going to talk about molecular compounds, electron sharing, single, double, and triple bonds, naming compounds, writing formulas, and then diatomic gases. Ionic compounds review. Ionic compounds are the combination of ions. So for example, sodium ion and chloride ion make sodium chloride. This formula represents the ratio, and that's going to be really key, guys. It's the ratio. So NaCl means that there's one Na for every one Cl. And you can see that in the diagram here on the right, that every time there's one Na, there's a Cl that goes beside it, and then there's an Na right there, and so on and so on. They are composed of a metal and a non-metal and form a crystal structure. So for example, sodium chloride and calcium chloride are both salt crystals. Molecular compounds are different. They consist of atoms covalently bonded together. The elements involved are all non-metals, and that's going to be a key point. So some examples. N2O is nitrous oxide, and it's a gas used at the dentist to relax patients. NO2 is nitrogen dioxide, which is a poisonous toxin emitted from car exhaust, so make sure you don't get them mixed up. More examples. H2O, that's a molecular compound, making water. CO2 is carbon dioxide, which is a gas exhaled and created during combustion reactions. And we have CO, carbon monoxide, which is a lethal gas created during incomplete combustion. Ionic compound. In an ionic compound, the non-metal rips away the electrons from the metal because the metal loosely holds their electrons. This creates a positive ion and a negative ion, which stick together. Opposites attract. Molecular compounds. A major difference between molecular compounds and ionic compounds is that molecular compounds are made up of a non-metal and another non-metal, unlike ionic compounds, which are created through the combination of a metal and a non-metal. They're also called covalent compounds. So you might see molecular compounds, you might see covalent compounds, but they do mean the same thing. Molecular compounds. Molecular compounds share electrons to form a stable arrangement. So unlike ionic compounds, where one rips the electron from the other and then they're attracted through electrostatic attraction, molecular compounds are different. They're going to be stuck together because they're sharing electrons. The negative electrons are attracted to the positive nuclei of both atoms, which creates this attraction. So this hydrogen here on the left is attracted to this hydrogen on the right because the electrons in their orbits are attracted to the nuclei of each atom, keeping them together. Molecular compounds. Molecular compounds are formed when nonmetals share electrons to fill their outer electron orbit or shell. If we draw the Lewis structure for fluorine, we can see that it needs one more electron to become stable. It has 1, 2, 3, 4, 5, 6, 7. It needs 8, so it needs one more. It can share one electron with another fluorine atom. If we draw the shared pair of electrons between the two atoms, we get this diagram here. Now they both have 8, right? The one on the left has 1, 2, 3, 4, 5, 6, 7, 8, and the one on the right has 1, 2, 3, 4, 5, 6, 7, 8. These two are going to be shared. They're going to spend some time on the right and some time on the left, but it's going to create a mutual attraction between the fluorine atoms. Many molecular compounds are predictable. So how will oxygen bond with hydrogen to form a molecule? Well, first we draw the Lewis structure for both. So we have the Lewis structure for oxygen and hydrogen. Notice that oxygen wants to share 2 electrons and hydrogen wants to share 1. Therefore, we need 2 hydrogens. So we're going to put the shared electrons between the atoms. So we have here, so hydrogen was this green circle, oxygen is the blue X. So you can see how they're going to be shared. So these guys are shared and these guys are shared. This creates the attraction between the atoms. The resulting molecule, H2O, includes one oxygen atom with 8 electrons in its valence shell and 2 hydrogens that each have 2 valence electrons. So they're good. Hydrogen only needs 2, so it's fine. Oxygen needs 8, it's fine. Molecular compounds. How will carbon bond with hydrogen to form a molecule? So we have the Lewis structure for carbon, we have the Lewis structure for hydrogen. Notice that carbon wants to share 4 electrons. It has 4 unpaired electrons. 1, 2, 3, 4. Whereas hydrogen only has 1. So therefore, we need 4 hydrogen atoms. We're going to put the shared electrons between the atoms, and the resulting molecule, CH4, includes 1 carbon atom with 8 valence electrons, so it's full, and 4 hydrogens that each have 2 valence electrons, so each of the hydrogens is full as well. Molecular compounds. Not all molecular compounds are as predictable, however. So for example, how will oxygen bond with carbon? Well, first we're going to draw the Lewis structure for each atom. Carbon wants to share 4, and oxygen wants to share 2. If we add one more oxygen, each oxygen can share 2. So that's what we have right here on the first diagram. This creates carbon dioxide, which includes a double bond between each carbon-oxygen. So we have a double bond here and a double bond there. The double means that there is 2 pairs of electrons. However, if oxygen will share 2 and donate one of its other electron pairs, oxygen can form with just 1 carbon atom. This creates carbon monoxide, which includes a triple bond between the carbon and the oxygen. And here we have our triple bond right here, 3 pairs of electrons. So again, this is just situational. Depending on the environment, carbon and oxygen will either create a double bond or a triple bond. So as we just went over, there are 3 kinds of bonds. There's a single bond, where you have 1 pair of electron. So for example, water has a single bond between the H's and O's. We can have double bonds, where, like in our carbon dioxide on the bottom here, we have 2 pairs of electrons, 1, 2, 1, 2, and we can form a triple bond. For instance, carbon monoxide, where we have 1, 2, 3 pairs of electrons. Molecular compounds, naming. So we need a very flexible naming system for covalent compounds to reflect the many different bonding possibilities. To name a covalent compound, we start with our atom that is to the left on the periodic table, or lower if it's in the same group. We're going to write the name of the atoms with the prefix. So this is a thing that comes before, indicating the number of the atom in that compound. And then we're going to change the ending of the last atom to "-ide", similar to what we were doing before. So here are the prefixes that you need to know: mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. So note, the mono is emitted on the first atom. So if we have CO, we write carbon monoxide, but we don't write monocarbon monoxide. CO2 would be carbon dioxide because there's two oxygens. So we find the 2 and we write di. Naming compounds. So for example, P4O10. Our compound is created from phosphorus and oxygen atoms. We're going to use the prefix tetra because we have 4 phosphorus. We're going to use the prefix deca for oxygen because there's 10 oxygens. And then we're going to change the name of oxygen to "-ide". So our final answer becomes tetraphosphorus decaoxide. Check your understanding. C2H4. Carbon's going to have the prefix di because it has 2. Hydrogen, we're going to change the ending to "-ide, and we're going to use the prefix of 4. So I want you to pause the video and write the name for C2H4. So when we put our prefixes in, we get dicarbon tetrahydride. Writing formulas. So when we're writing our formula, the leftmost element goes first. So for example, carbon oxide. Carbon is first on the periodic table, so we're going to put it in first. Carbon, it has no prefix, therefore we're going to write C. Monoxide, mono means 1, therefore oxygen has 1. So they're going to write it as CO. Check your understanding. Another example, nitrogen dioxide. Nitrogen, N, has no prefix, therefore it's just N. Dioxide, di means 2, therefore there's 2 oxygen atoms. So our answer becomes NO2. Check your understanding. So I want you to pause the video and name the following 3 compounds. So the first one, C is carbon, so we're going to write it as carbon. There's no subscript, so it's just carbon. And then there's 4 fluorines, so we're going to say tetrafluoride. H2O, we all know stands for water, but we could also call it dihydrogen monoxide. Okay, so for the last one, PF5. The P stands for phosphorus. There are 5 Fs, so we're going to say penta, and the F stands for fluorine, so fluoride. Phosphorus, pentafluoride. Check your understanding. Pause the video and write the chemical formula for the following 2. So the first one, sulfur dioxide. Sulfur is an S. Di means 2, and it's oxygens, so we know it's going to look something like that. So we're going to write SO2. Dicarbon tetrahydride. Carbon is C. There's a di in front of it, so 2. Tetra means 4, and hydride means hydrogen, so H4. So we're left with C2H4. Molecular compounds, diatomic gases. So molecular compounds show an incredible variety in structure, physical, and chemical properties. However, there are categories that further divide covalent compounds into categories with common properties. So for example, diatomic gases. When 2 atoms of the same type form a covalent molecule, the result is often a colorless, odorless gas. Molecular compounds, diatomic gases. The halogens, oxygen, nitrogen, and hydrogen, form diatomic gases. These compounds are named, so element name, gas, not di-element name. So for example, N2 is not dinitrogen, it's nitrogen gas. O2 is not dioxygen, it's oxygen gas. And H2 is hydrogen gas. So we got to remember what these are. So it's the halogens, so that's going to be our group 7. Oxygen, nitrogen, and hydrogen. These are all going to form our diatomic gases and are going to be named like this. Exceptions that do need to be memorized. CH4, that would be carbon tetrahydride, but there's a common name for it as well, and that's called methane. H2O2 would be dihydrogen dioxide, but it's also called hydrogen peroxide. And H2O we know as water. NH3 is also called ammonia. O3 we call ozone. And that concludes our lesson on molecular compounds.